This technical grower talk is about peat manufacturing. Peat moss is the backbone of our business, and in fact it is the backbone of most horticultural substrates that are used today for either for greenhouse production or even nursery productions. However, the characteristics that make peat ideal as the main ingredient in growing media, they can be jeopardized if it isn't harvested, conditioned, or packaged conscientiously. Pardon me. So over the years, we've always strived to improve our quality, and by bringing improvements to the operation in either from bog opening to storage and anything in between, Berger really has developed an expertise in the way that it produces its peat. Now, there are many different steps involved in peat production, and we'll take a look at all these steps from prospecting for new peat bogs all the way to the packaging and the storage of the peat. So first is site selection, and that is really a key component in manufacturing a high quality peat moss. What Berger does is, the first thing we do is we send experts to the prospective sites to assess the quality of the bog. Now, the quality of the bog isn't just the size of the bog, it encompasses a lot of different things. The first thing we do is we characterize the overall potential of the site in terms of surface area, the degree of decomposition of the peat moss, the density of the peat, and also we take different depth measurements throughout the bog, because a bog isn't necessarily a flat area. There are bogs develop as many different hills, so we have to take different measurements to evaluate the overall potential of that site. If we take a look at this picture here, this is actually a virgin bog. So first thing we'll do is we'll construct an access road to get to the bog. Obviously we need that to be able to bring our machinery in to actually start working in the bog. The next step will be to remove all the larger trees and shrubs that are present in the bog, and then we'll plan actually the layout of the fields. So this is what a layout for a field will look like once we've actually removed the top layer of the living sphagnum, which actually will end up being the next step in this presentation. But it's just to show that we have to basically plan that out in terms of what natural habitats are present in the bog. So there are certain areas of the bog that will be preserved if there is a lake, for instance, or if there is a particular species of an animal, a bird, or a frog that's endangered. We will actually reserve an area for that species so that we don't actually disturb its natural habitat. So next step will actually be to create the ditches to allow the drainage. So once we've actually drained the bog, and this is actually a ditcher to show how we create those ditches, and once the water has actually evacuated from the bog, we can actually harrow roughly to remove the large roots and the sticks. So this is what a harrow looks like. It's basically big machinery that's pulled by a tractor, which has sticks that will actually pull out those, well, sticks, I guess. Once that's done, we actually wait for the surface to dry, and then we'll harrow with a different equipment, which is a light harrowing, and that is really to more to flip the peat particles to actually dry the entire surface of the peat. And then once that's done, we can actually go in with our harvesters, which we'll see a little bit later on. But another important step is to classify the plates. The plates are actually, if I go back here, this is what is considered a plate. A section between two ditches is called a plate. So the next step is really to characterize each plate, and to do that we'll do a density test, we'll do some particle size testing. We really want to evaluate what the coarseness of the peat that will be harvested from that plate will be. And that's just to be able to store the peat properly, do the proper separation, so that when we blend the peat in our manufacturing facilities, we get the results that we want. The classification is done many times during the production or during the harvesting season. So we have an employee whose sole purpose is really to go from plate to plate and reclassify the peat to make sure that it's still within the correct coarseness. And that really allows Berger to constantly adjust their peat blends in order to perfectly match the desired specifications for the various BP series products that we offer to our customers. As I mentioned, the next step, once we've harrowed lightly, is to go in with our harvesters and actually harvest the peat. So basically a harvester is just a huge vacuum cleaner, if you will. We have different variations of the harvesters. We have harvesters with 2 vacuum heads. We have harvesters with 4 vacuum heads. In fact, when we plan out for the layout of the bog, we'll actually measure the space between the ditches so that it takes one harvester 2 runs to actually harvest the entire plate. So we only harvest high quality blonde peat with little decomposition, and the goal there is really to have the highest quality for our products. The decomposed fraction, which is once we get down to the lower levels of the bog, is really left undisturbed. And the reason we do that is to optimize the restoration process. So once the harvester has gone through the peat bog, it will actually dump the harvested peat into piles at the end of the plates. Each pile is different, is basically a different grade of the peat, which has been classified, as I was mentioning earlier. As we harvest, we'll cover the peat as much as possible to prevent rainfall which would fall on top of it, or any weed contaminations that could occur. So that's an image of the specially designed tarp. And actually, it's interesting about this. One thing that's interesting about this tarp is we've actually worked with the company to design it so that it prevents any contaminants, any rainfall, but it also allows for gas exchange so that the peat has no chance of self-heating or composting, if you will. Another thing we do is we monitor the temperatures of the piles, because obviously self-heating peat is detrimental to the characteristics of the peat. So by monitoring the piles with the temperature, if temperatures go up, we can actually quickly bring that peat into the factory and basically package it in either skyscraper format or our smaller baled formats. So what happens next is we have loaders that come in and they load the peat, pardon me, they load the peat onto basically bulk trucks that will bring the peat to the factory into the different hoppers that we have. So we have multiple factories for packaging peat, and the reason we package it as quickly as possible is basically to preserve the quality of the peat for a longer period of time. This is an example of one of the hoppers that we have at one of our manufacturing facilities in Baie-Saint-Anne. We actually have one hopper here and we have another hopper here. So what that allows us to do is to basically add one coarseness of peat here, add a different coarseness of peat here, let's say a coarse 1 and a coarse 3, and then we can blend a different percentage of each of those coarseness of those different grades of peat to obtain the BP product that we're looking to produce. And then it's actually our star screen system that allows us to really control the particle size of the end product. So we can play with the speed of the stars to actually increase or decrease the particle size depending on the results that we're getting. In fact, our star screen system has the particularity of being a variable speed star screen. We have a certain speed at the front and a different speed at the back, and we can control those individually to really optimize the screening process. The goal of the screening process is really to obtain that consistent particle size, but it's also to remove any sticks that were left in the material when we were harvesting. Once we've gone through the sieving system, we actually do frequent particle size testing to make sure that we're within the specification that we want, and if necessary, we can readjust the speeds of those star screens to basically bring back the particle size either up or down from according to the result we got. So throughout the process of going through the factory, we try to minimize handling as much as possible to really make as little damage to the fibers as possible. And what really creates a lot of the uniformity we have with our products is the fact that we do so much blending with our materials. So we're blending peat in the bog from the different plates according to the coarseness of the plate, and then we are blending the different grades of coarseness at the factory to get our BP products that we're manufacturing. And then when we're producing growing media, we're actually blending peat from different production sites. So for instance, in Quebec, we'll bring in peat from New Brunswick and use peat from our bogs in Quebec to actually manufacture our growing media to get even more consistency. Once that's done, it's really going to the packaging system. So we have different packaging formats that we can offer. We've got the 3.8 compressed cubic feet bales. We've got 6 cubic feet compressed bales, and we also have the skyscraper towers, which are 110 compressed cubic feet, which we see in this picture right here. We actually have conveyor belts that can, depending on what our customer needs in terms of packaging, we have conveyors that can be adjusted so that the same peat can go to different packaging systems. Skyscrapers are actually a good way to reduce labor and plastic weights for our customers. Now, once the peat has been packaged in a compressed format, the advantage is that it can be stored for longer periods of time. It can also be conveniently shipped to our Berger mix factories for further blending and superior stability when producing our BM series, like the BM6, the BM1, the BM4 Euro, all our different products. And it's easily used during the winter to manufacture our high quality growing media. This is an example actually of one of our bogs. This is actually Baie-Saint-Anne bog, and we can see here the sections that have been opened and the sections that will be opened in the future. We open these sites gradually because we're constantly reclassifying our peat in the bog. We know that we need, for instance, 60% coarse 1 in Baie-Saint-Anne with 40% coarse 3 to create a BP coarse product. Then we'll open the bog as a consequence of that by opening 60% of a section which is coarse 1 and 40% of a section that is coarse 3. And that really allows us to basically save our resources and use them only gradually. This is a list of all the different peat harvesting sites that we have. We have actually 5 different sites in Quebec: Saint-Modeste, Rivière-Pentecôte, Saint-Fabien, Chemin-du-Lac, and Sainte-Hélène. We also have 2 different manufacturing sites in New Brunswick, Canada. In fact, we have a 3rd one that has added on to that, or at least we have expanded to the Baie-Saint-Anne bog by purchasing some bogs from a different company. So that is actually in New Brunswick, Canada. And we also have 2 different bogs in Manitoba, which is Hadashville and Deer Lake. So numerous harvesting site is great for Berger because it allows us to produce high quality sphagnum peat moss every year, regardless of if one area has a poor harvest season because it's very rainy in that area. We can compensate by harvesting more in a different area. So Berger understand that peat needs to be handled carefully along the entire production process. So it's really our quality control system and our attention to detail that allows us to manufacture consistently uniform peat products that are identical regardless of where it was harvested, conditioned, and packaged.